Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are studying classification of progressive waves. Um, Actually, progressive waves are those waves in which the energy is transferred from one point to another point. Those waves are called progressive waves. So this whole chapter is divided into two parts. One part is progressive wave, the other part is stationary waves. Okay. In progressive wave, the energy will be transferred between from one point to another point, while in the stationary waves, the energy will be constant between the 2 points. Means the energy will not be traveled throughout the wave. It means in stationary waves, we have to confine the energy between the 2 points. We have to maintain the energy between the 2 points. And while in progressive waves, the energy will be transferred from one point to another point. Okay. Uh, Basically, we are studying classification of progressive waves. So we classify the progressive wave into two forms. One is the transverse waves. One is the transverse waves. Okay. How we can define the transverse wave? The definition is written in the book. So I'll not write the definition to save the time. So I'll write as in short, when vibration of the particle of the medium vibrates perpendicular to the direction of propagation, that is called the transverse waves. When the vibration of the particle is perpendicular to the propagation of waves, that is called the transverse waves. Okay. Suppose uh, if we have a string which is clamped with a stick or with a solid medium, so this is a string which is fixed to a rigid support. Okay. Now we know that there are atoms in the string. Yes, there are a lot of atoms in the string which are closely attached to one another. Okay. Now this end is the free end. Now I'm going to hold this free end and I'll give some jerk. When I started jerk, then these waves will be produced in the string, and waves will be produced. So crust and trough will produce. The upper portion is called crust, the down portion is called the trough. The upper portion is called crust, the down portion is called trough. What is meant by crust? Crust mean when the particle of the medium vibrate in upward direction. Trough mean when the particle of the medium vibrate in downward direction. Okay. Now look, when I give the jerk to the free end, then continuous waves will produce, and these waves will travel towards right. So the propagation of the wave is towards right. This is the direction of propagation. So propagation is towards right. And now if you look out to the particle, let us consider this single particle. This single particle is vibrating up and down. Up portion mean crust, down portion mean trough. So the vibration of the particle is up and down. If the vibration of the particle is up and down and the propagation is towards right, so both are perpendicular. The propagation is towards right and vibration is up and down, vertically up and down. So it means that both are perpendicular. So if both are perpendicular, these waves are called the transverse waves. So transverse wave mean string waves are the transverse waves. Okay. Now look at the water waves. Suppose we have water waves. Remember, the surface of the water waves are transverse, while the deeper water is longitudinal. The shallower water is transverse, while the deeper water is longitudinal. Suppose these are the molecules of water. Okay. Now, if I drop a stone into the water, when I drop the stone into the water, the molecule will start vibrating. So the molecule will start vibrating. The upper portion is called trough. The upper portion is called the upper portion of the vibration is called crust. The down portion of the vibration is called trough. So the wave will move towards right. So the propagation is towards right, because the energy is transferring from one point to another point towards right. So the propagation is towards right, while the vibration of the particle is up and down. So it means that vibration is perpendicular to the direction of propagation. So water waves are called the transverse waves. So transverse wave consists of trough and crust. So in this way the energy carry throughout the medium. Okay. Remember, the particle are vibrating on its own place. It do not translate along with the energy. It just transfer energy from one particle to another particle. For example, if we talk about the string, so remember, these molecules are attached to one another by intermolecular force. So it means that when you disturb this molecule will drag this molecule as well. because these molecules are attached with one another with a strong intermolecular force. So it means that whenever you give energy to a single molecule, that energy will transfer to the other molecules. So each and every molecule will transfer the energy to the neighboring molecules. So it means that only energy will be traveled while the molecule will vibrate on its own place. Okay, remember, in the wave, the energy is transferred only. The molecules are not transferring. So it means that there is no transfer of mass. There is only transfer of energy. Okay. Now we are studying the speed of transverse wave. So remember, the speed of transverse wave is represented by this equation. So look at the equation: v is equal to t into L divided by capital M. Okay. What is T? T is the tension. What is L? L is the length of the medium, length of the string, and mass. M is the mass of the medium. Okay. Where this formula comes from? So this formula can easily be derived from dimensional analysis. You can easily derive this formula from dimensional analysis. For example, taking left hand side is speed, and the unit of speed is meter per second, and its dimension is lt minus 1. These are the dimension of left hand side. Now taking right hand side is t into L divided by M. This is the right hand side. So remember, what is the unit of tension? What is the unit of tension? The unit of tension is Newton. What is the unit of length? Meter. What is the unit of mass? Kilogram. And what is the value of Newton? Newton is equal to kilogram meter per second square. And meter as it is, kilogram as it is. Okay. Kilogram cancelled. So meter into meter square per second square. And under root and square will be cancelled. So its dimension is also equal to LT minus 1. So left hand side and right hand side have the same dimension. So this formula can be proved by dimension analysis. Okay. So remember, speed of transverse wave depends upon the tension in the string, the length of the string, and the mass of the medium. Okay. You can vanish this length from here. So if you shift this length to the downward, so it will be look like T divided by M by L. And what is M by L? M by L is called density, small m. What is small m? Small m is the linear mass density. So it is equal to mass per unit length. Small m is equal to mass per unit length. So this small m representing the linear mass density. So it means that speed of transverse wave depends upon the density. It means that whenever a medium has high density, the speed of transverse will be smaller. For example, if you look out to the honey and water, so the speed of transverse wave will be maximum in water as compared to honey. Why? Because the honey has greater density, so that is why the speed of transverse wave will be smaller. So it means that these are the factors of speed of transverse waves. Now, come towards longitudinal waves. Longitudinal waves, the topic of longitudinal wave is 8.3.2. Actually, the transverse wave was 8.3.1. 8.3.1 it was, and this is 8.3.2. Okay. Longitudinal waves. Okay, now we are talking about longitudinal waves. So I will not write the definition of longitudinal waves due to save the time. So I'll write just in short that the vibration of the particle of the medium are parallel to the direction of propagation. Propagation means traveling, okay? So when the particle of the medium vibrates parallel to the direction of propagation, these waves are called longitudinal waves. Okay. In longitudinal wave, the vibration will be parallel, while in the transverse wave, the vibration will be perpendicular to the propagation. Okay, here. Now look at the tuning fork. We have a tuning fork which has two prongs, and there are air molecules, and this is air. Air mean listener, receiver. Okay, this is our air, which is the receiver, and these are the prongs. Okay, if we strike the tuning fork by a rubber pad, its prong will start vibration, If the prong will start vibration, so this prong will move towards right. Suppose if this prong is moved towards right, it will hit this molecule. If the prong is moving towards right, so it will hit this molecule, and this molecule will flow towards right. So this molecule will hit this molecule, and this molecule will come back to its original position due to elasticity. So it means that this molecule will have get a push from the neighboring molecule. So this molecule will be moved forward, and it will hit this molecule. Whenever it hits, this molecule will come back to its original position, but this molecule will be get pushed to in forward direction. So this molecule will go and hit this molecule and will come back. This molecule will be get pushed and will be hit this molecule and will be get come back. This molecule will be get pushed and will forward and come back. So the molecule vibration of the molecule is back and forth, to and fro. So the molecule is moving forward and backward, and the propagation is moving towards right. So the propagation is moving towards right, and the molecule is back and forth, and back and forth. So look at the vibration. The vibration and propagation both are parallel. If both are parallel, so these waves are called longitudinal waves. So remember, sound waves are longitudinal waves, or the spring waves are called longitudinal waves. Okay, remember, when the prongs moving from A to B, suppose this extreme point is A, this extreme point is B. So if the prong is moving towards from A to B, so it means that it will push the air molecule, and the air molecule will be get compressed. Okay, so the ink is gone now. So wait a minute, I'll take another pen. Oh, welcome back. Okay, let us consider look at again. Suppose I'm going to explain it again. We have a tuning fork, and this tuning fork is vibrating. So this is one extreme point A, it's another extreme point B. Okay, when the prong moving towards right, means from A to B, so the molecule of air will be get compressed, means the molecule will come closer to one another. If the molecule come closer, so it means that volume will be smaller, and pressure will be high, and the density will be high. So this is called compression. This is called compression. Okay, now when the prong will move from B to A, so when it move from B to A, so the molecule will be get relaxed. So it means that the volume will be greater, the pressure will be smaller, and the density will be smaller, because when the volume is greater, pressure and volume are inverse, and the density and volume are also inverse. So when the molecule get relaxed, this is called rarefaction. So it means that in longitudinal wave there is compression and rarefaction. So longitudinal wave move in the form of compression and rarefaction, while transverse wave move in a form of crust and trough, while longitudinal is moving in the form of compression and rarefaction. The basic difference is that these two waves having different vibration, means in one wave vibration is perpendicular to the propagation, in other wave the vibration is parallel to the propagation. Okay, now we are talking about the speed of transverse, the speed of longitudinal wave. Okay, so if we talk about the speed of longitudinal wave, the speed of longitudinal wave is equal to Young modulus divided by rho under root. Okay, this is actually the modulus of elasticity. V is equal to E by rho. Okay, so it is called the bulk modulus E, or it is called the Young modulus. Actually, it is a bulk modulus. We will study inshallah in the second year the bulk modulus. Okay, so bulk modulus is equal to stress divided by strain. What is stress? Stress is force per unit area. What is strain? Strain is change in volume per original volume. This is strain. Okay, what is rho? Rho is density. Density is inversely proportional to speed, and Young modulus is directly proportional to the speed. Remember, this Young modulus explain elasticity, means when the value of the modulus of elasticity is maximum, it means the medium is more elastic, and whenever the value of the Young modulus is smaller, is minimum, it means that the medium is less elastic. So it means that the bulk modulus representing elasticity. if the value is greater, if its value is greater, it means that the medium is more elastic. If its value is smaller, it means that the medium is less elastic. Okay, so elasticity is directly proportional to speed of longitudinal wave, and density is inversely proportional to speed of longitudinal wave. Okay, now where this formula comes from? This formula can easily be proved from dimension analysis. So we are going to prove this formula by dimension analysis. Okay, so look at here. We have E by rho under root. Now taking left hand side is speed, and the unit of speed is meter per second, and its dimension is LT minus 1. Okay, now taking right hand side, what is right hand side? Right hand side is E by rho under root. What is the value of E? What is the unit of E? The unit of E is Newton per meter square. Okay, what is the unit of rho? The unit of rho is kilogram per meter cube. Okay, now meter square and here meter cube will be cancelled, so it will be kilogram per meter. So this meter is in double division, so will be moved up, so it will be Newton meter per kilogram. Okay, what is Newton? Newton is equal to kilogram meter per second square, and meter as it is, kilogram as it is. Okay, kilogram will be cancelled, so meter into meter, meter square per second square, and the square and root will be cancelled, so it is meter per second. So the dimension is LT minus 1. So left hand side and right hand side have the same dimension, so it means that this formula is dimensionally consistent. So the formula for the speed of longitudinal wave is E by rho under root. Okay, this is the speed of longitudinal wave. Now there are small terms. Frequency is defined as the number of vibration per second, and time period is the time taken to complete one vibration. You have already studied this definition in the 10th class. Number of vibration per second is called frequency, the time taken to complete one vibration is called time period, and the amplitude is defined as the distance between mean position and extreme position, or it is called the maximum displacement. Amplitude is called the maximum displacement, and the definition of intensity is energy transmitted per unit area per unit time. This is the definition of intensity. R. Remember, energy per time is also called power. So the definition of intensity is power per unit area. This is another definition of intensity. These are the small definitions, and you know that the definition of wavelength. Remember, the distance covered by the wave to complete one cycle is called lambda. R. The distance between the two consecutive crusts. Look at here. The distance between the two consecutive crusts, or the distance between the two consecutive trough, is called lambda. Or suppose we have longitudinal wave, so this is compression, this is rarefaction, this is compression, and this is rarefaction. Okay, the distance between the two consecutive compression is called lambda, the distance between the two consecutive rarefaction is called lambda. So these are the definition of lambda. Wavelength, you have already studied this definition, that is why I'm going to repeat it very quickly. So you know that these definitions. First definition is the distance covered by the wave to complete one cycle. Another definition is the distance between the two consecutive crusts. Another definition is the distance between the two consecutive troughs is called lambda. Another definition is the distance between the two consecutive compression, and the distance between the two consecutive rarefaction, that is called the lambda. Okay, now I am talking about the journal of wave speed. So generally, the definition of wave speed is defined as the distance covered by the waves to distance covered by the waves per unit time. Per unit time is called waves. The distance covered by the wave to per unit time is called wave. So wave is equal to S by T. Okay, remember, the definition of speed is S by T. The distance covered by the wave per unit time is called wave speed. Okay, when a wave covered one cycle, suppose, so in one cycle the distance is covered is called lambda, and the time taken is called time period. So putting the values of distance, so the distance covered in one cycle is called lambda, and the time taken in one cycle is called time period. And 1 over t, 1 over t is equal to f. 1 over t is equal to frequency. So this is another formula for the wave speed. So this is the general formula for the wave speed. Okay. This is all about this topic, classification of mechanical waves, classification of progressive waves. If you have any query, any question, you can ask in comment section. I'll answer inshallah. Okay, take care. Allah Hafiz.